Hi, this is Mr. Ward. I'm going to do a quick key for the exit ticket for today for PreAlgebra week 16, day 3. And the first question comes from this selection here. So a class has 12 girls and 10 boys. A hat contains the names of all students in the class. Select representatives of the class to attend a meeting. The teacher draws two names from the hat without replacing the first name. Okay, so what is the probability of two girls? Well, we've got 12 girls and 10 boys, so there is a total sample space. The total possible outcomes for that first draw is 12 plus 10. So 12 plus 10 is 22 possible outcomes. And the first draw is going to be 12. There's 12 girls, so there's 12 desired outcomes. Now, that's the probability of the first girl. And then the probability of the second girl is going to be out of a smaller number because we didn't replace. So now it's out of 21. And what's the probability of getting the second girl? Well, now there are, if they got the first girl, then there are 11. So this is a dependent probability, which makes the first event alter the second event. So now that's why it went down to 11 out of 21 for the second pull. Now we have, I'm going to pause for just a second. Okay, so I apologize, I was interrupted because I had to take the recycling out. So here we go. We have the probability of two girls. There's 12 out of 22 for the first draw and 11 out of 21 for the second draw. So we can work that out. I'm going to cross reduce a little bit first. 11 and 22 can factor down to what's 12 over 2 times 1 over 21. Then I can also factor a 3 out of 21 and 12 and a 2 out of 12. So that will equal 6 out of 1 times 1 out of 21, which then becomes 2 out of 1 times 1 out of 7, which then simply becomes 2 out of 7. So there's a 2/7 probability of pulling two girls out of the class. Now, with boys, it's a similar structure. It's still out of 22 to begin with, so we can just copy pasta this, but the numerator changes because there's 10 boys in the class, and then if we got a boy on the first draw, now there's 9 boys that we could draw from. So once again, we can do a little cross reducing. 10 over 22 becomes 5 over 11, and 9 over 21 can become 3 over 7, and that's just a little easier to work with. So that becomes 15 over 77. And 15 over 77 and 2 over 7, we could actually work out what those are. 15 over 77 is approximately 19.4, 19.5. So I'll put that in there. That's about 19.5%. Okay, rounded. And 2/7 is going to be about 28.1% rounded. Okay, because 2/7 is 0.28 for 2, so 0.285. So I'm sorry, that's actually be 28.5.6 rounded. Okay, 28.6 rounded. So, oh, that's not a decimal. That should be a decimal. There it is. Okay, what's the probability of a boy and then a girl? All right, well, let's work out the probability of a boy first. Okay, and the probability of a boy, again, is 10 out of 22. And then the probability of a girl, there's 12 of them, but if we pulled someone out of the hat, now there's out of 21. Okay, and so we can start simplifying things. I'm going to start by saying 5 out of 11. And then 12 out of 21 becomes 4 out of 7. And then we don't have anything to reduce anymore, so that's 20 out of 77. And let's work out what 20 out of 77 is. Change that to a 20. Okay, and we end up with 25.97. I'm going to round that to 26.0. So, which is about 26.0% rounded. Okay. What's the probability of a girl and then a boy? Well, let's check that out. There were 12 girls out of 22. And once we've pulled from the hat, now there are still 10 boys, but there's 21 students left to pull from. You might notice something here. You don't have to do any math because up here it's 10 times 12 in the numerator, and here it's 12 times 10 in the numerator. Up here it's 22 times 21 in the numerator. It's still 22 times 21 in the numerator. So all we've done is we've flipped the position of the numerator. The denominators stay the same. So we actually have the exact same probability of pulling a girl and then a boy. And that is, of course, about 26.0% rounded. All right, I hope that was helpful for you.